This is the first in a series of videos that I'm putting together to cover what I call a little magic with IoT, to demonstrate some of the work, I guess if you can call it that, it's actually been a hobby of mine, some of the work I've been doing with a friend of mine to add some automation to some scenery that he's built. But I'll get to more about that in a little bit. This is the first in that series, and in this presentation I'm going to talk about the kind of the overview and background of what our vision is for doing, and then talk about the design of how we plan on designing the solution to provide the capabilities that we envisioned. Later videos will go through demonstrations of how things work. I'll talk about the prototypes we've created and then demonstrate how things work and the ultimate solution as well. As a little bit of background, this friend of mine, he and his wife bought their first home, and they are huge Harry Potter fans, and they're also extremely artistic. And in their home, they decided that they wanted to, in their basement, create a room that was themed after Harry Potter. And they had a bar down there, and they wanted to create some storefronts, which is a picture you see shown here. It's a little hard to see, but there's actually 3 pieces to this storefront that mimic scenes from Diagon Alley within the Harry Potter series. On the left is the Taddings and Twilfits shop, which I think I have the name right. I'll just refer to it as TNT. In the middle, there's the door that takes you into the shops. And on the right is the ice cream or candy shop. I refer to it as either one. The idea here is to leverage the experience that I have with using Arduinos and actuators and servos and sensors to bring a little automation to what's in these scenes, and by scene there's 3 scenes here. Bring some automation to those scenes so that it makes it more interactive than just looking at it. And that's what we mean by magic. So we sat down and we thought about some things, and going through the thought process we came up with 2 scene-specific ideas and then 1 modular design idea that I came up with. Of the scene ideas, the first is that we wanted to be able to trigger audio, motion, lighting as a result of 2 different situations. A user approaching a scene and standing in front of it looking in the window, that might cause something to happen. And secondly, and this is where the magic comes into play, is if they were to issue a magic spell with a wand, have something get triggered by that as well. From a design perspective, one of my design goals was to design this in a modular way so that each module, and by module you'll learn what I mean about that in a little bit, has a very specific purpose. This would allow us to take these modules and reconfigure them within a scene or within many scenes to accomplish different tasks and animations within each scene. So what is a module? 2 main types are sensors and actuators. From a sensor perspective, there are 2. There's an IR module, which senses an IR signal like you might get from a TV remote control, but in this case it would come from a magic wand. And there are proximity modules, which trigger based upon someone standing in front of a scene. It actually measures that there is someone standing in front of it, the distance that they're standing, and then triggers accordingly. Then there are actuators, and there are 5 different actuators that I've created. There's a servo module, which is a motor that turns based upon data that's given to it. So in this case, the servo motor will spin a certain direction, a certain distance, and that can be used to move objects within a scene. In this case, we're thinking about making a chocolate frog hop or have the door knocker knock on the door. The second module is a relay module, and this is probably the simplest of them because it's simply an on-off switch. And that module will turn something on or off. In this case, we wanted to use it to turn on a fan, to blow a dress on a mannequin within the TNT store to make it look like a spirit was moving. There's a DMX and RGB modules. Those 2 modules are used for lighting. The DMX one uses the DMX protocol to output RGB and white values to 1 or more DMX lights to change the lighting within a scene. Similarly, an RGB module runs and sends RGB values to an LED light strip so that if they wanted specific lighting in specific places, they have a couple of ways of doing it, either through DMX controllers or DMX devices or an LED light strip. And then the last actuator is an MP3 module that plays a requested MP3 audio track. And if you think about each scene, that could be a frog croaking, it could be some background noise, it could be the ringing of a bell if someone knocks on the door, things like that. So those are the types of modules that we envision creating. Now, how will all this work together? This diagram kind of covers how all this will work. So if you look at this screen, I have the TNT store on the left, the door in the middle, and the ice cream shop on the right. And then I have icons and a little legend there on the right that show each type of module that we have. So first of all, there are the sensor modules, and they are depicted up here up front. They would obviously be in the front of the scene so that if a person over here comes in and stands in front of a scene, those sensors can sense that they are in fact there. Then we have the actuator modules, and these actuator modules will be throughout the scenes, and there will be different combinations of them in each scene depending upon what we need them to do. Some of them are the DMX modules, there's relay modules, servo modules, and MP3 modules that will be used for various purposes within each scene. Then there's the controller, and I haven't talked about the controller yet, and we'll talk about that more as we go through this, but the controller is kind of the brains of everything, so that when a sensor senses that a person is standing in front of a window, the controller then receives a signal, and here I'll depict that next. So when a person stands in front of a window, a signal or an event is sent to the controller. The controller interprets that event and says, aha, I see what's happened. Someone has waved a wand, or someone is standing in front of my window. Therefore, I'm going to send events out to the appropriate actuators within that scene to take action accordingly, either by turning on a relay or spinning a servo or playing some music or changing the lighting, or a combination of all of the above. So that's how this process and how the module and controller integration will work. From a design perspective, one of my goals was to standardize the design of our modules as much as I possibly could. Each module is a Wi-Fi enabled Arduino board. An Arduino is a single board computer that connects to the local area network and is configured with logic to support a set of properties and events. They also run a web server on them, which you'll hear more about later, but that's used so that I can configure those modules when needed. What you're looking at here is the set of common properties and events that each of the modules supports. From a property standpoint, each module needs to understand the network that it's working on and how to connect to that network, so obviously the SSID and password is necessary. It needs to know how to communicate with the controller. The protocol that's used is called MQTT, and it needs to know where that controller is, and that's what the MQTT server IP and server port are used for, so that it knows where to connect to send its events to. To uniquely identify each module, we need two pieces of information, and that's necessary because a module could exist in, or the same module could exist in different scenes. That combination of data to identify a module consists of the scene it's in and the name of the device itself. And then lastly, there's a service port, which is a port again on the server that allows me to remotely access and program each device, each module, without having to hardwire connect to it. From an event perspective, there are outbound events that each module emits, and there are inbound events that it reacts to, that it consumes and reacts to. So from an outbound event perspective, each module, when it turns on, will emit out to the controller to say that it is ready, meaning it's turned on. It will let it know when it is started, meaning that it is ready to accept events. It'll let it know when it's stopped, meaning that it's still running, but it will no longer respond to any events that it receives. When it does receive an event, and I'll talk about the inbound events in a minute, it will let the controller know that it is running and it's executing one of those events. It will also let it know that it's been triggered. And then when that event is done being processed, it will notify to the controller that it is done. From an inbound event perspective, each module will react to a start event, which says, okay, you are ready. Turn yourself on so that you can now accept events and react when I tell you to. I being the controller. There's a stop event, which tells it to stop reacting to events. There's a go event, which says, do what you're programmed to do. And then from an administration perspective, there's a config event, which puts each module in a configuration mode, which you'll see when we get to the demo, that allows me to configure the properties on the device itself. And then there is a check event, which will signal to the module to go out and check to see whether there is any software updates that have been made available to it to be uploaded or to be downloaded to the device and refreshed and then begin running. So that is the base capabilities of all the modules. There's also the controller, and you heard me talk about the controller, and I talked about this a little bit. It's actually a Raspberry Pi device, and it's running Mosquito MQTT. That is the event processing platform that I talked about. It's also running Node-RED, and Node-RED is a programming environment that allows you to visually program logic, including the processing of MQTT events. And I'll show you a slide about how that works, and there may be a presentation later in some detail on how I have Node-RED used in this platform. The controller receives events from the sensor modules, and it sends events to the actuator modules to react based upon what it senses from the sensor modules. Now, looking at each of the type of sensors, I gave a brief overview of these, but just to give you a sense of some of the additional events and properties that exist on each of these. First, we'll talk about the IR sensor module. Again, this is a sensor module, so it doesn't react. It actually publishes details back to the controller. So in this case, the new event that it supports is the triggered event. So when it receives an IR code, it turns around and sends that IR code back to the controller to react accordingly. The proximity sensor module is also a sensor, so it also sends a triggered event back to the controller when it is triggered. However, the way it is triggered is when something is within its proximity. So in order to determine what proximity means, this module has a range which says, okay, if something is within a specific range, then send the triggered event. It also has a range check delay, and that's there so that we can configure it to say, hey, you know what, once you sense that someone is standing in front of you, wait this period of time before you check again. That way it's not always repeatedly taking the same action and sending triggered events back to the controller all the time. It might check every 5 or 10 or 20 seconds. The servo module is the first of the actuator modules. This drives a servo motor based upon configured properties. Those additional properties you see listed here. There's a bottom and a top which depict the beginning and end distance of how far the servo motor will rotate. There's a pause property, which represents the time that the servo should pause when it reaches the top of its rotation before returning back to its bottom position. And then there is an up speed property, which tells it how quickly that servo should spin from the bottom position to the top position. And then from a custom event perspective, there's a go event, which the controller can send, or the UI, when we talk about the UI, that can say, hey, trigger yourself or do what you're supposed to do, rotate and pause and return back to the bottom. That's how it gets triggered. The relay module, as I mentioned, is very simple. It's simply an on-off switch. So you can turn that relay module on or off. There are events to tell it to turn itself on and then turn itself off. But there's also an event that says pulse. And that says turn yourself on for your configured duration of seconds and then turn yourself off again. The pulse seconds property tells how long the relay should remain on before turning itself off. Next is the DMX module. This module controls a set of DMX lights according to signals sent to it. And the way the DMX lights work is they work on an RGB setting. So we can set a series of RGB values to it. And it will set one or multiple DMX devices hooked up to it to that RGB value or a set of RGB values. There's also a brightness event that will set the brightness of those RGB or of those DMX devices. And then there is an event to turn the device on or off. Similar to the DMX module is the RGB module, except that it runs an LED light strip. And it has a few extra properties in it. It has a set RGB to set an RGB value. It also has a fade RGB, which will allow it to fade from one color to another. We can set it to white. We can fade it to white. and we can turn it on or off. The MP3 module, as you might guess, is used to play music or sounds in each scene. You can load it with a series of tracks. They are just MP3 files. And then you can tell it from an event perspective. You can say play track number 2, and it will play track number 2 or 1 or whatever track number you tell it to play. The second custom event is end play. So if one of your tracks is a longer track, you can interrupt that track by sending the end play event. And then lastly, there's a set volume event, which allows to set the volume of the playback through the connected speaker. This diagram kind of shows how all the modules play together. On the left and right are the sensor modules. In the center is the controller, and it sends events out to each of the actuator modules at the top to react according to what the sensors sense. At the bottom, I've depicted the responsive UI, which I'll show a slide for in a little bit and get into more detail when we get into the demo. But that's used so that Adam or I or whoever can control things outside of the sensors themselves and change the scene dynamically as we seem fit. This is a quick screenshot of Node-RED and the graphical utility that's used to program the logic. And as you can see in the middle, all the nodes in the center, all of these nodes are used and are connected together to represent logic. Each of the purple nodes is an MQTT either inbound or outbound event, and then each color depicts a different type of node that may be a function that has to get executed or a test that has to be done or a value that has to be set. But that could be an entire presentation in and of itself. And lastly is the user interface. These are two screenshots of the same user interface, one on my phone and one on my iPad, that show the responsiveness of it and just give you a sense of what the UI looks like. I will go into detail about how the UI works and how we can use it to control devices in the upcoming videos. So that goes over what the whole initiative is, about what we're doing, and the design about how we're planning on solving it. So stay tuned and you'll get more details. Thanks.